said go up and to the right?
Oh, I was sorry. I'm like, yeah, I understand that.
So give me an answer. Does this data set go up and to the right?
Yes.
All right. Negative means down and to the right. And in this country, in the English language, we always go left to right. That's just the way it is. I don't make the rules. But we all agree on that.
Hmm.
Okay. So that means it's either A or B. How do you decide whether it's strong or weak or maybe moderate? Do you remember that from class?
Um, it's depends on where the dots are.
Okay. So would you say that this is strong or weak?
Strong.
I would agree. It's strong because they're very close together. Weak would be if they were spread apart. Is that okay?
Hmm.
All right. Now, it's not so much the answer that matters here, it's the why. It's you being able to say, this is why. Okay, so for number 3, take a look at this.
It would be B, weak, negative correlation.
It is weak negative correlation. Good. All right, let's look. Uh, let's look at another one here. Now, what is the scenario that they're trying to describe here? What do you
Um,
see in the graph?
the how much money? Wait,
What does
the
it say
value,
in the bolded thing here?
the relationship,
Okay, what is the relationship between what two variables?
age in years and value in thousands of dollars.
Okay, so a new car is up here. A 15 to 20-year-old car is down here. Is that reasonable to you or not?
Uh,
Like,
um,
what do you know about car prices?
I mean, I know like they cost, how much they cost and stuff.
Right. So a new car, do you expect to pay more for a new car or a used car?
New car
Why?
because it's not used and stuff.
That's right. There's more miles on a used car, so you would expect to pay less.
Mm.
Okay. All right. Now, for the next one, I'm going to not show you the graph. I'm just going to put the scenario in front of you. And the axes, this is age and this is height. What do you expect? Which direction do you expect the data to go?
Um, um, uh, up to the right.
Yes. We generally expect age and height to sort of go up to here, but what happens after a certain age?
You grow taller.
Do you grow taller forever?
No.
Just for a while. So maybe initially it's like that. Okay. All right, good. Let's look at another one here. Sorry, give me a moment here trying to snip one. I guess these don't have the right thing here. All right, let me grab another problem here to put in front of you. Okay. All right. What do you think here?
Um, weak positive correlation.
Okay. Now, why would this relationship be weak positive? What Tell me in your own words what you see here.
Um, well, I can see that the two dots at the bottom are like on the line perfectly. And since it's going upright, it's gonna be a positive, but then all the other dots are not close to the line.
Oh, right. So what I'm really asking you about the variables, like why would this be a positive correlation? What is it that's going on here?
Um, it's going up to the right, or
Why? What is it about the scenario that makes that reasonable?
the
So so if you haven't done so, I mean, read the black, the bolded writing, what is the scenario that they're talking about here?
temperature and the numbers of customers
What
in
are
an
they buying?
ice cream.
Okay, so why would that matter? Why would temperature matter for that?
Because like if it's hot, then like the sales price are gonna go like higher and stuff.
Right. Do you want an ice cream cone today?
No, it was cold today.
Yeah, but what about, 3 days ago on
Yeah.
Saturday? Yeah, maybe you did. And that's the point here. You should have like some reasonableness of of the answer. All right. Okay. Let's take a look at another problem here and see if we can. So first thing I want you to do is look at this graph. Tell me what you see in your own words.
A cluster of like dots.
Yeah, in terms of the variables though.
Oh, um, the average vehicle speed is like it goes. Oh wait,
I know this is more difficult. This is more like English than math, but that's what's required here. It's more descriptive.
well, like it's since it's all like clustered, like
Think about the variables. What happens as speed increases or decreases, or volume increases or decreases?
the speed increases when there's less traffic, and then the speed decreases when there's more traffic.
Why does that make sense? Like, why is that reasonable from what you know on the road?
Because like when you're in traffic, it's like most likely everyone's like stopped and going slow. Then like when there's no traffic, it's like you can just like go and stuff.
Exactly. Exactly. So the what you said is completely correct. In a multiple choice test, though, you have to be able to match up the what you said with the correct answer. So
Hmm.
which of these says what you just said there?
Would it be B?
Why is it B?
Oh wait.
I'm not saying you're wrong. I'm just asking why is it B?
Um, because when the traffic is like when you're in traffic, you go slower, and then you're not in traffic, you go faster. So
Good. All right. So is this positive or negative correlation?
negative.
And is it strong or weak or moderate in your opinion?
Uh, strong.
Okay, I agree. Yeah, strong negative. All right, let's look at another one here. I want you to describe what you see in your own words again. Take a minute there. Tell me what you see.
Um, well, as like when you're younger, you'll most likely have like a smaller foot size,
Okay,
but
shoe size, yep.
it also depends on like your like well, I don't know, when like some kids are like some people are like short and stuff, so it's like their feet might be smaller and stuff.
There's always exceptions, right? There's people that are short with big shoes and small with, or large with, small shoes. I mean, um, are either of these trend lines correct?
Um, no.
Yeah, they're neither of them are correct. There's actually no trend. Did you guys talk about that in class?
Yeah.
Okay. All right. So here is a new question for you to think about. I want you to read this and make a graph where you label each axis. So the axis and the axis here, and then put some data to show like what you think is going on up here. I'll be right back with you.
Um,
Hang on just a second. I'll be right back. All right. What do you think goes on the x-axis here?
um, I put class time,
Okay, so time, that's pretty common. What do you think goes on the y-axis?
um, to the test scores.
Yeah, the score. So what direction do you think the graph goes?
Um, hmm,
Do you think the
well,
more time you study improves your test score or does not improve your test score?
improves your test score.
Okay. So which direction should it go? Give me words like up, down, left, right.
I guess that would be a negative, like down.
Okay. So give me an example of like this ordered pair. Like give me an ordered pair A and B.
Um,
Like A is how much study time and what's your score?
um, uh, 20 minutes and 100.
Okay. And so B is like you studied for I don't know, 80 minutes and you got a 15. Is that what you meant?
Oh, oh, okay, I see. Yeah, so it would be a positive thing.
Positive what?
Positive, it would be a positive trend line, like go.
Yes, it's positive correlation. So yeah, it's going to go up and to the right. That's where I was looking for those words, up and to the right. All right. Can you give me an example of something that goes down and to the right? So so this is the more you do something, the less of something else.
Um,
Temperature is sometimes a good one to use, like as it gets colder, as it gets warmer.
mhm. Okay, so the temp, so, oh, wait, does it have to be a negative or can it be, like, can it be up to the right or no?
I want you to try to think of something that's down to the right. That's the harder one. That's the one they might give you on a test or quiz.
Okay.
So try to think of something that you do in what that you do more of when it's colder or less of when it's hotter.
Well, I thought of like how the amount of time you spent driving and like the amount of time, like the amount of gas it is.
Okay, so time spent driving can go down here. What do you know about the gas?
Well, the more you drive, like you'll need gas more and
So this is the amount of fuel. Okay, that is true. That's a good one. But let's try to use the one with temperature here. So let's put temperature here. So as it gets colder, what do you do more of when it gets colder?
um maybe like with like your AC
Buy
and
or
heater,
activities. Say that
like
again.
like your AC and like your heaters and stuff.
Okay. So as the temperature goes down, your gas bill goes up.
Hmm.
Okay. All right. So the next type of problems I want us to do are these basically there's some graphing problems. And what I'm looking for is just a rough sketch. Okay.
Hmm.
Which means you don't have to be accurate at all. Um, you do want to decide which variable goes where. Typically, time goes on your x-axis. So you said you have some paper. I want you to draw something, and put those dots on your paper, however you see fit.
Okay. Okay.
You have something down?
Yeah.
Okay. So like I said, you don't have to be very accurate. You just sort of have to be in the vicinity. So one, I'm going to do hours over here. So 8, 1, 2, 3, 4, 5, 6, 7, 8. And actually, let me get a little more room here for this. Um, 83. Let's see, I got 4, 1, 2, 3, 4, 5, 6, 7, 8. So 83, and then you just kind of offset there, like so 786, 774, 8, 88, 6, 76, 5, 63, 7, and 90, and so on here. I may have skipped a few. 4 and 60, 9 and 89. So are you seeing any sort of trend here? Do you think the trend is positive or negative?
Positive.
Yes. And is it a strong, a weak, a moderate correlation? What would you say?
Um, it's kind of, I guess I'd say it's like strong.
Okay.
Like,
All right. Yeah. I mean, you might say it's strong positive. So, okay. So there's like I said, there's the next kind of problems they give you are generally like graphing problems.
mhm.
I'm trying to see if I don't know. This is what I meant. We've kind of come into the end of like uh what we can do on this lesson. Do you happen to know what you're going to be working on later this week in the class?
Um, no, I think we're ending it like here, and then we're getting like a new book and stuff.
Okay. All right. Let's take a look at one more of these. This one's gonna be a little bit harder to graph, but just take your time. Um, just see if you can come up with a some sort of a graph here. Why don't you put the first column in X and the second column in Y?
Can you hear me?
Yes.
I don't know what just happened to my screen.
It's okay. I'll just reshare here. Maybe that will help.
Yeah, it just says it's like on the app. It's weird.
All right, so I am sharing again. So we're looking at that's a calories hot dog, sodium hot dog.
I don't know why I can't see. It's it looks like it's
Try
and you,
one thing you could do is try leaving the room and rejoining. That would could also help.
it doesn't give me the option. It's weird.
There's a toolbar with some options there.
I think
I
I got it.
You got it? Okay.
Now it did it again. What's happening? It's like not letting
Like I
me.
said, you could exit the room and then maybe rejoin. I can remove you. I can put you in the waiting room. You could rejoin as well.
Yeah, I'll try leaving and rejoining since
Okay, sounds good.
Okay, I'm back.
All right. Should be seeing my screen now.
Yeah, now I can.
Yeah, so just make a quick sketch of this. I'm suggesting to use calories as X and milligrams of sodium as Y. Just see if you can kind of figure out the direction of this.
Okay.
All right, so let me give you two options here. Does your graph look like this on the left or this on the right, roughly?
Um, on the right.
Yeah. So the idea here is that as the calories increases, the sodium in the hot dog also increases.
Mm-hmm.
This is called a direct relationship because they go in the same direction. And if calories were to decrease, sodium would also decrease. And as we kind of talked about, these are easier to come up with compared to the other ones.
Mm-hmm.
All right. So I'm debating what we should do now. I guess I'll give you one more of these and then we'll go review, or maybe we'll stop early. But let's look at one more here. Could you make a quick sketch of wind chill and I'm sorry, wind speed and wind chill temperature for me, please?
Mhm. Okay.
You got it down?
Yeah,
All right. So does your graph look more like the one on the left or the one on the right?
the one on the right.
Yeah, so this is called inverse relationship. As speed increases, temperature decreases. And see, these go in the opposite direction now. As speed decreases, temperature increases. When they go in the opposite direction, and these are harder to think about because we usually try to think of things as being positive, going in the same direction.
Mhm.
And that's why you struggled to come up with an example. It's a little bit odd because they're kind of negative anyway to think about.
Mhm.
All right, let's just do a couple of review problems here. See if we can get another couple minutes out of our lesson today. What is 3x minus 2y minus 4x plus 6y? Can you simplify that for me, please?
Uh-huh. Would it be negative 1x plus 4y?
Good. All right. So let me grab I'm trying to grab one here. All right, so here is another graph. And let's say that this point right here is 16 comma 8.5. And let's just say they don't give any other good points. I'll just make one up here. Let's say it's this point right here that I've added is 11 comma 6.5. Do you remember how to find the slope between 2 points?
Um, oh,
Do you
yeah.
remember this formula at all?
Uh-huh.
Okay. Why don't you try this formula? Remember the ordered pairs go x1, y1, x2, y2.
It would be 2/5.
It is 2/5. Very good. All right. You want to do one more problem or do you want to stop here?
We can do one more problem.
All right. So I got another graph here. We're going to find the slope again. This time I want you to use these 2 points right here that I've circled. Could you give me those ordered pairs first? Give me this first ordered pair here.
105.
Okay, so that's the one, that's the second one
Oh,
here.
sorry.
That's 5 comma 100. So the X comes before the Y. How about the other one, please?
1 and 60.
All right, see if you can come up with the slope for us, please.
Would it be 40/4?
Okay, what does that divide to? What is 40 divided by 4?
Um, 10.
It is 10. Very good. All right, good job. Let's go ahead and stop there. Let's go stop a little early for today.